For decades, we thought we understood the octopus, a simple invertebrate, a soft-bodied sea creature with no bones, no social life, and no real future. It lives for 2 years and dies. End of story. Except that almost everything we thought we knew turned out to be wrong. Not slightly wrong. Fundamentally, embarrassingly, completely wrong. And the more we correct those mistakes, the stranger the octopus becomes. Because it turns out the animal we dismissed as simple is doing things that nothing else on this planet does, in ways we still can't fully explain. So today, we're going back to the beginning. We're going to look at what we got wrong, why we got it wrong, and what the octopus actually is. And I'll warn you now, by the end of this, you're going to look at the ocean very differently. Let's start with something we were completely wrong about for a long time. The way the octopus reproduces. Because it is one of the most extreme, most brutal, most fascinating things in the animal kingdom, and almost nobody talks about it. The male octopus has a specialized arm called a hectocotylus. That arm detaches from his body and delivers sperm to the female. The arm detaches, and in some species, the male dies shortly after, not from injury, not from exhaustion, from a programmed biological shutdown that kicks in the moment reproduction is complete. His own body turns against him. His digestive system stops working. His optic glands flood his system with hormones that accelerate aging so aggressively that he deteriorates in days. We used to think this was just what happened, a side effect, an unfortunate biological cost. What researchers now believe is that it is the plan. The male is essentially dismantled by his own biology the moment his genetic material has been passed on, so that he doesn't compete with his own offspring for food. Evolution decided that the father is more valuable dead than alive. The female doesn't fare much better. She lays her eggs, attaches them in long strings to the walls of her den, and then spends weeks, sometimes months, guarding them without eating. She fans them constantly with water to keep them oxygenated. She cleans them. She watches them around the clock, and the whole time, she is starving. By the time the eggs hatch, she is so depleted that she almost always dies within days. She never meets her children. She is gone before they are large enough to interact with anything. Every octopus that has ever lived came into the world completely alone. No parents, no family, no one to learn from, starting entirely from scratch. And yet here they are, using tools, solving puzzles, planning ahead, escaping tanks. Which brings us to the second thing we got spectacularly wrong. As far back as the 1950s, researchers were running maze experiments on octopuses and finding that they could not only solve them, but remember the solutions days later. That result was quietly filed away because it didn't fit the framework. Invertebrates weren't supposed to have long-term memory. The consensus was that complex memory required a vertebrate brain. So the data was noted, and then more or less ignored for decades. It took until the 1990s and 2000s when video documentation became widespread and impossible to dismiss, for the scientific community to begin seriously reconsidering what the octopus actually was. A simple animal doesn't premeditate an escape. A simple animal doesn't carry tools across the ocean floor for future use. A simple animal doesn't figure out how a valve works by playing with it repeatedly until the mechanism makes sense. We weren't discovering something new about the octopus. We were finally accepting something it had been showing us for 70 years. Now here is where it gets genuinely strange. Because the octopus didn't just evolve intelligence differently from us. It evolved it in a place that should have made intelligence nearly impossible. The deep ocean is one of the most extreme environments on Earth. Crushing pressure, near zero temperatures, almost no light, very little food. It is the kind of place that strips animals down to their bare essentials, where anything expensive gets eliminated. And intelligence is expensive. It requires enormous caloric investment, complex neural architecture, and enough time to actually use it, which is why deep-sea animals are almost universally simple. Slow metabolisms, minimal brains, basic survival behaviors. The deep ocean doesn't produce geniuses, except that it did. Because some of the most cognitively complex octopus species ever documented live in the deep ocean. There are over 300 known species of octopus. A significant number of them live in conditions where, by every rule we have for how intelligence evolves, they should not be intelligent at all. We don't know why. We don't have a clean explanation. What we do know is that octopus neural tissue is packed into places that make no structural sense if you are thinking in terms of vertebrate biology. 2/3 of an octopus's neurons are not in its central brain at all. They are distributed across its arms. Each arm contains enough independent processing power to react, navigate, and make decisions without any instruction from the central brain. Cut off an arm. It keeps moving. It keeps responding. It keeps attempting to find food for a mouth that is no longer there, for up to an hour, because it doesn't know it's been separated. It is, in the most literal sense possible, still thinking. That architecture, a distributed nervous system capable of semi-autonomous processing across multiple limbs, has no real parallel anywhere in vertebrate biology. It didn't evolve from anything we recognize. It appeared in the fossil record relatively rapidly, without a clear step-by-step precursor showing how you get from a simple mollusk nervous system to this. One paper, controversial but not easily dismissed, proposed that the genetic complexity required for this kind of neural architecture couldn't have assembled itself in the time available, and suggested the possibility of genetic material arriving from outside Earth. That paper was widely criticized, but the underlying question it was trying to answer, where did this complexity come from, and why does it look like nothing else on this planet, has never been cleanly resolved. What we are dealing with is not a simple animal that surprised us. It is an animal that evolved an entirely different solution to the problem of surviving in a complex world, built from different materials, on a different timeline, in conditions where it shouldn't have been possible. And the deeper we look into how it works, the more it becomes clear that we haven't been studying a curiosity. We have been slowly, reluctantly, finally beginning to understand something that has been operating on its own terms in its own way for 500 million years, long before us, entirely without us, and completely unbothered by everything we thought we knew.